question is we have to find out the transfer function directly, straightforward. That means C of S by R of S we have to find out. So we know that the definition of the transfer function is a block diagram is given. So one way of solving the problem is directly, if you know the reduction techniques in the block diagram, so directly you can approach that method. Otherwise one more technique is also there, and that is, first you have to convert the block diagram into signal flow graph. Then you have to do the transfer function with the help of signal flow graph technique, right? So that is the second method. So generally the people usually go for signal flow graph technique if the block diagram given is the complex one. So but if you observe this system, it's a very simple system. Only two cascade elements are there in the forward path, but two series elements are there in the, I can say parallel elements are there in the there in the feedback path. So that's why this is very simple method. So that's why we will try to simplify this with the help of block diagram reduction techniques only, right? Now if you, I am just reducing the network by combining these two blocks into a one block, and by combining these two feedback path into a one feedback path. So these two are in parallel. If the two networks are in parallel, then that will be added. So if two networks are in series, that will be multiplied in block diagram reduction technique. So I am following those techniques, I am applying those techniques here. Now I am reducing this block diagram by like this. So this is my forward path here, G1, G2, because these two are connected in cascaded. So that's why these two are multiplied. Now in feedback path, these two will be added. So 1 plus H1. So because the gain of this is the gain of this feedback element is H1, but the gain of this feedback element is nothing is mentioned here. So that's why this is a unity feedback. I can say directly unity feedback, because the output is directly fed to here. The directly is fed to here, but the output is fed through a block, that is H1. The gain of the feedback path is H1 here, but the second path the gain is 1. So that's why I directly taken 1 plus H1. So now I am reducing this, the control the transfer function equal to, we know that G by 1 plus GH, because this is a negative feedback. So that's why G by 1 plus GH. What is G here? G1, G2, and 1 plus, what is G? Again G1, G2, that multiplied by 1 plus H1. If you solve this, what you will get? G1, G2 by 1 plus G1, G2 plus G1, G2 into H1. So what is your answer? So obviously the option will be D. We have to go for option D. So option D indicates G1, G2 by 1 plus G1, G2 H2 plus G1, G2. So the option is here. Question is, the pole zero configuration of a system is shown below. The magnitude of the transfer function will be. So here he is asking for a pole zero plot is given here. So simply, and here he is asking for, so what is the magnitude of the system with respect to frequency. So if you observe the options, all are in terms of the frequency. That means option A indicates increase with the frequency, option B indicates decrease with the frequency, and then independent of the frequency, and option D indicates initially increase then decrease with the frequency. So these are the options given here. So first, if you observe the system, then we will go for the option. So here if you observe the system, there will be symmetric pole zero configuration here. If one pole is here and the symmetric 0 is here, and one more pole is here and the symmetric 0 is here. Now if you convert this into an open loop transfer function model, okay, so if you convert this into an open loop transfer function model, then that will get transfer function equal simply S minus 1 to S minus 2 by S plus 2 into S plus 1. Now this is the transfer function. Now if you find out the magnitude here, what is the meaning of magnitude? So if you take if you substitute S equal to j omega here, so what you will get? Minus 1 plus j omega and minus 2 plus j omega, because S equal to j omega, then 2 plus j omega and 1 plus j omega. Now we have to find out the magnitude. So magnitude of the transfer function is 1 plus omega square under root 2 plus 2 square means 4 plus again sorry 4 minus it will be 4 minus, because j omega whole square means minus 4 minus omega square, sorry 4 plus omega square, right. So that by again 4 plus omega square 1 plus omega square, this will be under root. If you solve this, we will get simply 1. So the transfer function, the magnitude of the transfer function is simply 1. So from this what we can say, there is no term called frequency here. So that's why the option will be here, the magnitude of the system or magnitude of the transfer function will be independent of the frequency, because we got a transfer function equal to 1. Again I am repeating the question. First here the question is given, so first I am converting into pole 0 part, the pole 0 location into transfer function model, and then I find out the magnitude for, by substituting s equal to j omega. Then I find out the magnitude. After finding the magnitude, we got a magnitude equal to 1. So that's why, so it will be independent of the frequency. So that's why we have to go for option C.
In this problem, it is given that a box contains 5 black and 5 red balls, of which 2 balls are drawn one after the other without replacement. Now we have to find the probability that the both balls being red. Now the total number of balls are 10, of which there are 5 red and 5 black. Now when we are drawing the first ball, probability of getting a red ball is out of the total outcomes, that is 10 to 10C1, we are selecting one from red, that is 5C1, which is nothing but 5 by 10 equals to half. Now when we are selecting the second ball, probability of getting red is 4C1 by 9C1. The reason is we are not replacing the ball. So out of 10 balls we have taken 1 ball, so the remaining are 9 balls, and out of 5 red balls we have selected 1 red ball, that is there will be only 4 red balls left. So the answer will be 4 by 9. Now the required probability is nothing but the product of these two cases, which is 1 by 2 into 4 by 9, which is 2 by 9. Option D. Now we have to evaluate the integral z plus 5 by z square plus 2z plus 5 dz. Now in order to find this integral, we have to find the poles of the denominator, that is z square plus 2z plus 5. In order to find the poles, we'll equate it to 0. Now the value of z will be minus 1 plus or minus 2i. Now the value of r is nothing but root over minus 1 square plus or minus 2 square, which will be root 5, always greater than 1. That means these roots, these poles lie outside the unit circle. So if the poles lies outside the unit circle, the value of the integral will be always 0. So therefore z plus 5 by z square plus 2z plus 5 integral will be 0. That is option B. Now in this problem, the given function f is xyz cube. We have to find the gradient of f at 1, 0, 2. Now the gradient is nothing but delta f, which is nothing but dou by dou x of xyz cube into I plus dou by dou y of xyz cube into j plus dou by dou z of xyz cube into k, which will be nothing but yz cube into I plus xz cube into j plus 3z square xy into k, which is nothing but delta f. Now delta f at 1, 0, 2 will give you 8j. Just substitute the value of x as 1, y as 0 and z as 2. Now gradient is modulus of delta f, which is equals to modulus of 8j, that is nothing but root over 8 square, which is again 8. So the option B.
Here we have to find out the resonance